Hey, what's up everybody? Today we are going to start learning about how to create a build a controller and then start to wire it up and start the programming of it. So let's take a look at the materials we need first, and then we're going to start talking about what's going to happen from there. So for this project, you are going to need two joysticks. They look like these, right? These are analog joysticks. They consist of two potentiometers. Potentiometers can determine position of things. So we have a potentiometer for both axes, for the x-axis, which is left to right, of course, just like a graph, and the y-axis that's up and down. Both of these buttons also have a switch when you click on them down. Alright, so you're going to need two joysticks. You're going to need 8 male to female wires. Right now I have 9 here, but we're going to ultimately need 8. Again, one side is going to have male pins, the opposite side is going to have female pins. And you're also going to need some sort of controller frame, which is something that you're going to need to source or you're going to need to source your controller frame. This is something that we are going to upcycle, so we're going to try and find some recycling or something that's kicking around your house that, once had a purpose but maybe now doesn't. Something that we can shape, or that is already shaped, like something that we can hold in our hand comfortably. So I have a piece of foam that I've cut, but we need some sort of a frame, and you're going to need a hot glue gun to finish this up as well, to attach your potentiometers. Also, later on, you're going to need your ARM, your Arduino, your power supply, your breadboard power supply, all that type of stuff to actually program. We're going to talk about that in a little bit. So let's take a peek a little bit closer here. So again, when we look at one of these controllers, let's zoom in here. Alright. So when you look at the side of this controller, there are pins that come out. We have our ground pin, which again is going to ultimately get wired to ground. We have a +5 pin, which is going to go to 5 volts. We have a VRX, which is the potentiometer in the X orientation, which is actually this device found over here. You can see when I move this joystick, this white piece slides around. So that is the X axis. Then we also have what says VRY. That is our Y axis. Both of those are going to get plugged into inputs. They're going to go to analog inputs, which we'll talk about a little bit later on, because a potentiometer is an analog device. And then we also have the switch, which is the button that we can push on. So you get to kind of design how you want your system to be set up. For me, I'm going to set up my controllers so that when I push this up and back, for me, I'm going to control my right servo, which is going to move it in and out. When I tilt the left controller to the left and to the right, that's going to make my middle servo move and rotate around. On my opposite controller, I'm going to use my y-axis to control the left servo to bring our arm up and down. I'm not going to use the X for anything. And I'm going to use the switch on my right controller to open the claw when I push it down, and close the claw when it is let go. So, first thing I need to do is start my wiring. So I'm going to use colors again, you're just going to get random kind of ribbon cable, but you can start to pull these apart. There's really not a lot of reason why they all need to be attached. So for my ground and my 5 volts, I'm going to connect these together with a brown and a red wire. And again, if you don't have a brown and red wire, use something else. For the opposite side, I also need ground and 5 volts connected up for this joystick. I don't have any brown and red wires left, so I'm going to use blue and purple for this side. Alright, and again, colors don't matter, what they attach to matters. So pay attention to what they're attached to as you go through. So that's going to be like the power being delivered to both of these joysticks. Next thing, again, I'm going to use the X and the Y axis on my left controller. Maybe you want to flip that around though, but like that's totally up to you. So let's say that my X over here is going to be a white cable, whatever cable you have kicking around, and my Y is going to be orange. And then on this side here, I need my Y axis for my up and my down, and I need a switch. So let's see here. I'm just trying to reuse some colors, so I'll have to like trace a few things out. But I'm going to put my switch on a gray, and I'm going to put my VRY on this side because I only care about up and down on this other white cable. Now, once that's done, I'm going to take some hot glue, I'm going to put it on the back of your controllers, and you are going to hot glue your controllers so that the wires face towards the middle of your controller. Right? Once you've got that done, then you can kind of like rearrange your wires so that they're coming out the top. So, just like Martha Stewart or any other good baking show here, I already have this thing set up. But, same idea. Ground 5 volts, my X and my Y, ground 5 volts, my Y and my 5 volts. Alright, my colors have changed now, but same idea. So once this thing is hot glued, I did take a zip tie and kind of like hold my wires together. If Mr. Van Vliet has zip ties, you can do that. If not, it's not really that necessary, it's just a little helpful. But this is like the beginning of our controller. So let me jot down, I'm going to create a list, and I would suggest that you do too, what colors go to what things. Alright, and we're back. So, my left joystick, these are all my wire colors going to my different places. My right joystick, again, wire colors going to the different places. So, now it's time to start setting up our Arduino. We're going to skip setting up the breadboard to begin, or I'm sorry, not the breadboard, but the robot arm to begin with. We are just going to start testing and coding with an Arduino. So we need an Arduino, we need a USB cable, and we need a computer, and we need our joystick. So let's grab that stuff. So before we get into programming and like wiring this Arduino up, let's just talk about potentiometers in general. All potentiometers measure the distance something is moved or rotated. They come in different shapes and sizes. Like we have the joystick, which is one type. I actually have like a little rotating potentiometer here where you can like adjust this knob. There are sliders that are potentiometers. So like if you adjust the level of light like in your dining room, you're using some sort of a potentiometer as an input device. Potentiometers are analog devices. They can measure more than on and off, right? A digital device is like a switch. It's just off or it's on. There's nothing in between. Potentiometers, there's like lots of options in between. As a matter of fact, with any of the potentiometers that we use with an Arduino, there are 1,024 different options of positions that they can be in. And that's not really a function of the potentiometer itself, it's a function of the Arduino, and we'll talk a little bit more about that later on. Potentiometers are input devices. Either a user adjusts like the level that something turns, and like we can make our lights brighter, or we can make a character move on a video game. Or they're used as sensors. So like in high school robotics team, we would use potentiometers to measure like the rotation of axles sometimes and other things that we wanted to see if they turned or not. Potentiometers are like really common electrical devices. And potentiometers, I should also mention, they're just a variable resistor. And that resistance, which we're not going to get into like the math and stuff behind it, you'll learn about that in electronics and robotics at the high school if you choose to take that course. But when the potentiometer is at one end, there's like 0 ohms of resistance. And when the potentiometer is at the opposite end, there is all of the ohms of resistance, which different potentiometers have different resistance. This is a 10 kilo ohm resistor. I believe so are these, or potentiometer. That means that at the top end, there's 10,000 ohms of resistance versus 0. So like in the middle of this one, there's 5,000 ohms of resistance. And again, the ohms of resistance doesn't matter so much, but that's the thing that like the system measures and determines the position of the output. Alright, so let's start talking about wiring this up. So again, on the power side of your Arduino, we have VIN, 2 grounds, and 5 volt. We're going to use VIN and 5 volt to power our 2 potentiometers of 5 volt sides, and then we're going to use our 2 grounds for our grounds. So my left joystick is orange for 5 volts, my right joystick is red for 5 volts, so I'm going to grab a red and an orange. And for right now, we're going to connect these up. Later on, we're going to change this when we connect up to our robot arm, but for now, we're just going to leave that. Ground is black and brown, so I'm going to find brown. Connect that to one of my grounds, and my black is going to get connected to my other grounds. Alright, now, next to our power, we have an analog in. Alright, I am going to take my left joystick, my X, which is blue, is going to go to A0. My Y, which is purple, is going to go to A1. Analog, again, joysticks are analog devices. My green is my Y for my other joystick. That's going to go into A2. And then my switch is going to be a digital device because the switch is either on or off. We're going to connect that up to pin 2 on the opposite side. Now when you go to put this in, we start counting with 0, 1, 2. Never use pins 1 and 0 on an Arduino. They have like different jobs and you don't want to really mess with them. So let's jot down on the paper here like what went where. So for me, and again, your colors are going to be different, but you can do the same process. Blue is A0, purple is A1, green is A2, and yellow is digital 2. Alright, so that's my wiring done. Now we're going to start talking about getting like information from these potentiometers to the Arduino and then something we can do with it from there. So for that, we need to open up Arduino. Alright, so here we are in the Arduino program, and again, mine looks a little different than yours, same idea. So if we look down the bottom, my Arduino is connected, but it's not here. So let's go to Tools, Ports, open up your port. Unless your Arduino is connected to your computer and powered on, you're not going to see your port. So make sure that you see a little green light. That means you have power, you're on, you should be able to connect up. So later on we're going to add some robot-like code to this, but for right now we're just going to start off with seeing our joysticks move in what's called the serial monitor. So let's start off with some comments, my name, my project's title, which in this case is going to be Robot Joystick, or whatever you choose to call it. And we are going to create some variables today. So just like in math class, variables are like words or numbers that we associate with, or words or letters rather, that we associate with numbers. So we are going to type in int to create an integer, which is a type of variable. I'm going to type int, notice it turns blue. We are going to create a variable for vrx, and then this is going to be my left side, and that is going to be set to, which is one equal sign, A0, right? I'm looking at my list over here to determine what it is. Semicolon to end the line. Int vry left is equal to A1. Int vry right is equal to A2. Right? And again, these are my left joysticks and my right joystick. Int button is set to just a straight 2. Digital inputs don't need an A in front of them. I think that's about it. We don't need integers set up for like grounds and stuff. That's just where power is. We really only care about data. We're going to add more things up here as we go along today, but that's where we're going to start. I'm going to add some comments quick. So we're back. I added the comments. It's left joystick x-axis to A0. So it's left joystick y-axis to A1. So it's right joystick y-axis to A2. So it's right button to digital pin 2. So we are going to run into void setup at this point, and we are going to add like a few bits of code within here. So the first thing we're going to do is we're going to type the word serial with an S-E-R-I-A-L dot begin. And then in parentheses, we're going to type 9600. And then we're going to put a semicolon at the end. This opens a communication channel between your computer and your Arduino. And we're going to be able to see like numbers that our joystick outputs. We're going to have to use the serial monitor, which is in the top right corner, to be able to see that information. All right, and we'll get into that in a second. We're also going to do what is called pin mode, which we didn't need to do with joysticks before. But pin mode defines what a pin is and like what it's going to do. So pin modes can either be an input or an output. And in this case, like we've named the pins that we want to use up here. We're going to write each one of those first. So we're going to say VRX left. If I wrote it capital up here, it needs to be capital down here. Same thing with lowercase. Let me change X to a capital. So VRX left. We're going to put a comma after that. Then we need to tell it what the mode is. And in our case, this is an input. We're going to input information. So we're going to type all capitals, input. And then at the end of this, we are going to put a semicolon, okay? And this sets the A0 pin ultimately to an input, right? And again, A0 is defined by like up here in our integer. So again, copy and paste is a programmer's best friend. We have VRY left is an input. This is going to set A1. We have VRY right. It's also an input. That's VRY right is an input, and this sets to A2. Then lastly, we're going to say pin mode button is also an input. there we have our basic setup. So again, later on we're going to add more information to this to control our robot arm, but for right now we're going to continue on so that we can see some outputs and do some different things. So down here in void loop, we are going to, so this is a loop, we're going to, because these are inputs and because we need to basically constantly read how we change our inputs and then like later on adjust how we change our arms, we need to put all of this in the loop so that it continuously loops around to like check our code. So down here at this point we are going to once again create integers to store variables within. We're going to type int, and we get to create a new name. So I am going to create, it can't be the same as above, but I'm going to create a name that is very similar to above. It's going to say VRX left value. Okay, I'm going to add value to the end of all of these. So this is set to, which again is one equal sign, set to. An analog read, we are going to read we're going to read an analog device, and the pin that we want to read for this is VRX left. So before we move on, let me show you what we can do with this. So the next line here, we're going to write serial.print. Serial again is capital S, and we are going to first print the word VRX left, and maybe like a colon. You can add whatever you really want in here. Oh, I forgot. Oops, can't. These things need to be in parentheses. So we put parentheses at the beginning and at the end, and it is going to print exactly what you put in there. We're going to add a semicolon to the ends. Okay, so this is going to print the name. Okay. Then, next line of code, we are going to serial.print once again, except now we're going to add an ln to the end of this line, which is going to add a new line of like code after this. And in here, not in it's in parentheses, but not in quotations, we are going to say VRX left value, which is the integer or variable that we have created above, and this is going to print the value of the integer, aka a variable. So let me show you what I mean by that. So let's verify my code, make sure I didn't make any mistakes, which is totally possible. Okay, that actually worked out pretty good. In the top right corner, we're going to hit serial monitor, and yours is going to like pop up a new window, but on mine it pops up down here. Alright, I uploaded my code again, and now things are working. So over here you can see, and like this is scrolling really fast, like maybe almost 1,000 times a second, but we say VRX left, so that's the name of our value. That was in this first line, okay, it's the quoted part, and then we put the semicolon there. This is the value that it's reading, which is right here, okay? This line up here reads the value of the pot, potentiometer, and assigns it to the variable name. So down here, while this potentiometer is in the center, it reads like 525, 526. When I push it to the left, it goes to 1023. When I push it to the right, you see my numbers get smaller, all the way down to 0. So again, here's my going to the left, numbers get bigger, all the way to the left, all the way to the right. Now, none of my other joysticks are doing anything yet, right? I can move this thing up and down, it doesn't move it too much. It's really just when I turn my left X to the left or to the right that we're seeing values, all right? Now let's add our other potentiometers to this system. Ooh, yeah, and button is low. Well, we'll get back to button here in a second. So we're gonna add more to our process. And again, we are going to copy and paste. So now we're creating an integer VRY left, and that's going to be assigned to the VRY left, which again is now A1. We are going to print the word VRY left, and we are going to serial print the value of VRY left. So now if I click upload, it gets to be harder to see, but if actually, let's do something else. Instead of, we're going to go back to this here, we're going to remove this line from the first one so that we don't return. We're going to add a couple spaces in front of this one so we have like some space, and you'll see what I mean here in a second. When I go to upload this code, we're going to see it like right next to one another now. So now we see VRX to the left, VRY left, okay? And again, because I removed the LN, it didn't skip a line, and because I added some spaces before here, there's like a gap between my data. So now when I push my X to the left, it still goes to 1023, to the right, it still goes to 0. When I press my Y up, it goes to 1023, and down, it goes to 0. Okay, so now we can see our input and our output from both of these. And like, this is how joysticks and video games are programmed as well. We just use different variables, and we get different outputs depending on our sensor. So now let's add our right one. So we're going to control copy, control paste. Again, I'm going to go above, remove the LN so that we add like the same line. And now we're going to say VRY right value is equal to an analog read of the VRY right. We are going to print VRY right. And we are going to print the value of VRY right value, right? So again, these are coming from like above. VR right value is this variable here that changes. VR right is just like the name that we're calling it. So when we upload now, we are going to see 3 bits of serial information coming across our screen. And now my right one, when I press it up, in this case it goes to 0. Notice that that is the opposite of when I press the other one up, because the controllers like are like the pins face one another, so they're opposite. And then when I push this one down, as of right now, it's going to 900. That is because like the VIN is getting a slightly lower voltage. So this doesn't quite work out yet, but it's definitely working out close enough where you're not going to have to worry about it later on. We're going to like rewire it slightly different when you actually add your robot arm. So last thing we're going to do is we are going to get the value of our button. And before we do that, I need to correct a mistake that I made above. So when we go to pin mode, button input, we're going to use a slightly different type of system here. Alright, so right now I'm at arduino.cc. If you go to documentation and reference, it will give you like all of the different types of like syntax that you can use for the Arduino. We are going to look at, so see here we have input and output. We've been using input so far, but there's also what's called an input pull-up. So input pull-ups is going to it's going to tell us like if it's high or low. High is defined when we have a voltage like higher than 3 volts, and low is defined when it is less than 3 volts on a 5-volt board, which is what we're using. And that, so digital electronics things are either on or off. 5 volts means on, 0 volts means off. As we are not touching our switch using a pull-up, it's going to default to on. And when we push our switch, that is going to make it turn off. And the easiest way to do this is to simply, like, you could wire this like different ways, but we're going to use this input underscore pull up instead of just a straight up input. So underscore pull up, all one word, all capitalized. So down below here, we are going to create a new integer named button value, and that is going to be set to or equal to a digital read because it's in a digital port, and it's going to be on or off button. Semicolon. Okay, so here we're going to read the button. And again, we are going to serial.print, and in quotes, we're going to add a couple spaces, button value, and a colon. And then we're going to put a semicolon at the end, and then we are going to serial.print the button value. And that's going to be an ln there because we want a new line. And again, we're going to remove the ln from above because we want them all on the same line. So now when I upload my code, now we can see that my button value is 1, which means that it's on. And when I click the button down, it turns to a 0, which means it is off. Okay? Now we just need to know that, like, when you're not holding the button, it's going to be equal to 1. When you are holding the button, it is going to be equal to 0. So now we have all of our inputs set up. Things like change values. There's my VR left changing. My VX left is also changing. My right Y changes. And my button changes. So once you have that done, then we're ready to start considering like your arm itself. But at this point, you have like a joystick that is starting to work. So let's talk a little bit about adding like our servo stuff again. So we're gonna fly through this here a little quickly. At the top of our code, we are going to add, under sketch, include library, servo library again. Okay, so that gets included up there. And again, we're going to need to define our servos. So we have servo left, right, middle, claw. Okay, then in our setup, basically anywhere within the two parentheses, it could be above all of this, it could be below all of this, we are going to attach. So we're going to say claw.attach, that's in pin 8. Left.attach pin 9, middle.attach 10. Right.attach 11, right? Which is the same as it's been all along. Let me add some comment. So, let's talk now about, again, servos. Servos, we can control servos with values between 0 and 180. But you'll notice that, like, when we look at my serial monitor on the bottom, my values go from like 1023 over here to 0. They're a lot bigger. So we need to use a function that is called a map. So let's kind of talk about a map really quick before we get into that, and then we'll go from there. Alright, so again, we're looking at like the references page on Arduino, and I've opened up the map function. So map scales numbers. It scales like a value such as our like potentiometer input from a low value, which might be like 0, to a high value later on, which is 1023, and maps it to like something else. So for instance, here's an example. This is a variable name, y, is set to a map, that's our function, And then within parentheses, we have 5 arguments. That's what these things are called, arguments. The first argument is our input sensor value. All right, and in our case, it's going to be like our joystick values. So it's going to be like VRX left value or VRY left value, stuff like that. Then we have the low range of that system versus the high range of that system. Now, they don't literally have to be like a small number versus a big number. They just have to be like the bottom and the top of the values, which I'm going to show you here in a second. But remember how like the joysticks are opposite one another. So in one instance, when we push it up, it reads like 1023. And when it's down, it's 0. And in the other instance, it's opposite one another. We're going to like flip numbers around in here. But then on the output side, this low value is going to be mapped to this. So like when this value is equal to 1, Y, the output value is equal to 50. When this is equal to 50, Y would map it to 1. Okay? These two numbers are associated with one another, and so are these two numbers. So for instance, here we map X. 1 is going to be equal to 50, while 50 is going to be equal to negative 100. And again, when we look at the syntax, we have map, value, this is our input value, from low, from high, those are what our inputs are from low to high, and then too low and too high are going to be like what we output to the opposite side of our like set to sign. So for instance, our system is going to use 0 to 180 to control our servos. So let's start with VR, Y, left, and right. So when it goes up, it's 1023. VR, Y, left, rather. When it goes down, it's 0. All right, so again, we're going to create a whole new integer. So we're going to say integer. And we're going to call, again, my up and my down on my left is going to control the right servo motor. Okay, so I'm going to say right, but I can't just say right because that's the name of my servo. So I'm going to name this thing like right scaled value because we are scaling or mapping this output. So this is going to be equal to, and again, this is just a name that I've created. You can change it, but that's the variable that I've created and named it. All right. So now we're going to type the word map, which is our function, the thing that we're trying to do. And then again, in parentheses, we need 5 arguments. So the first argument that we need is what source data are we using? And in our case, we are using VRY left value. That is the actual like number that changes between 1023 and 0. So we're going to type VRY left value first. Then when it is down, it's equal to 0. When it is up, it is equal to 1023. So I'm going to say 0, comma, 1023, comma. Now I need my outputs. So to start with, I'm going to go 0 and 180. Honestly, if your controller, like when you go to move your servo or your potentiometer up, if your right motor moves backwards, and it's probably not gonna like be great for you because they're opposite one another. Switch these numbers around or switch these numbers around, one or the other, not both, so that they map differently. Because right now, if it's 0, it's gonna output a 0. If it's 1023, it's gonna output a 180. And if it's anywhere in between, like if it's halfway in between these numbers, it's gonna be halfway in between these numbers as well. So we're gonna put that in there. And now, I can say like right dot right. Okay, the second right is with our writing something down. We are going to now say write scaled value. And that is going to send information to our servo, and it's going to send it a number between 0 and 180 because it is the scaled value of this mapped information. Alright, so now we're going to create a new integer. We're going to call this the middle scaled value. So again, my middle is going to be controlled by my x-axis on my left joystick. And again, when it goes to the left, it's equal to 1023. When it goes to the right, it's equal to 0. So again, I'm going to type map. And now the input that I'm using is VRX left. And 0 to 1023. And we're going to do 0 to 180. And again, now we can say, okay, this is our middle servo.write middle scaled value. Okay. Next, we're going to do our last servo, not including our claw. Claw is going to be coming a little bit later. So we're going to say integer left scaled value is going to be equal to VRY right. This is the right joystick that's going to control my left servo, which is a bit confusing, but that just makes sense to me from like a controller perspective. Comma. For right now, I am going to flop these numbers around here because again, they're backwards. Over here, when it goes up, it's equal to 1023. Over here, when it goes up, it's equal to 0. So, I guess we can really look at the bottom too, but we're going to flip these. So I'm going to write 1023, 0, comma, 0 to 180. So for this one now, 1023 is going to be equal to 0, while 0 is equal to 180. So again, if it's in between these two numbers, it's going to be in between those two numbers as well. Now I can say, alright, so left dot right left scaled value. Whew. I know we got a lot going on here, but this is going to like help us out as we go through this system. So our last, well, let's get our robot arm connected up. Let's get things moving. Let's make some edits to our code before we start worrying about the claw. So, all right. So we have our arm. I still need my power supply. I'm going to need some other things, but right now I'm just really worrying about wiring, and then I'll worry about like the rest later on. So the first thing that I need to do is we connected our grounds and our VINs and our 5 volts and stuff like that originally to here for our joystick. We are going to switch these to our breadboard. So we're going to disconnect just those 4 wires, the VIN, the ground, and the 5 volts. And what was connected to VIN or 5 volts before is now going to be connected to like our 5 volt section on the breadboard, and what was connected to ground before is going to be connected to the ground portion of our breadboard. Alright, we're just like changing out where we're getting the power and the ground for. We're then going to go through and wire our arm like we have in the past. So look at your colors, line things up the way that they belong. Alright, so I added power to this. Again, things are connected up on my Arduino. Let's go back to the code. Still need to add comments here, which I will, but for right now I'm going to just move on. I'm going to try and upload. There might be some errors in my code that might jump out at us. No, somehow it seems to have worked out okay. So, See right now my arm is like starting to move. So let's see if we can like mess around with this. So if I bring my left joystick back, again my right motor moves back. If I push it forward, it moves forward. Freaking out. If I move my center's not working right now for some reason, so that's something that I need to check on. What about this one over here? Also not too great over here. Okay. Let's check some of that stuff out. Alright, it took me a few minutes going through my code, but here's my issue. I say just VRX left, I need to add value. Down here it says VRX right, I need to add value. It didn't give me any errors because they were like legit names, but they were the wrong names. So let's try to re-upload this again and see if that helps. That's the problem with copying and pasting if you're copying and pasting like bad code. Ooh, there we go, better. So now, if I pull this joystick on the left back, my right arm moves back. That's its like default position, which I do recognize is difficult to more or less see in my camera. When I go to the left, ooh, it did turn to the left, so that's cool. When I push it to the right, it does go to the right. When I'm with my right joystick, if I push it forward and backwards, it still does nothing. So what is up with that? VRight value. Let's double check here. My VRight value is equal to an analog read of the VRight. VRight value. Oof. Oh, left scaled value, left dot right. Yeah, well, that makes sense. Wow. See, this is the thing, like, this is true too. It's not just me. When you're working on robots, again, there's basically 3 points of failure that you could be dealing with, right? You have like hardware failure, so it's like, is it my motor that's wrong? You have wiring, you know, so it could be like a problem with wiring, and then you have programming that it could be a problem with. So like you got to go through and you got to like look at all of those components and be like, well, does my right motor move, or my left motor move for that matter? And like my left motor is like way down in there. So that's a little peculiar. So that's definitely something that I want to start with. So like, let's see if I can just like move my left motor. So I'm going to comment both of these things out. And instead I'm going to say just like left dot right 90, let's call it. Let's see if we can make that left motor move at all after this code goes in. Okay, so that did just go up. Again, like these things still move the other ways. So like left going 90 did work, like that's where it belongs in the middle. So let's pull that out. Let's see here. Left scaled value. So that's my servo name. Scaled value is set to the VRY right value. Alright, so one of my favorite little tricks to do is print information, right? So I added serial print left scaled value, serial print ln left scaled value. So now my left scaled value on my whole like system down here. And like it doesn't matter how I move my joystick, it never moves off of 180 degrees, which is like congruent with what's happening with the system. It's stuck in one position. And I'm like going through my code, and this is not just like it took me a moment to figure it out. Like, that's the hard thing about programming. Sometimes the mistakes are like right in front of you, and like a compiler doesn't pick it up or anything else. I forgot the word map in this line of code. Just like everything else, it said map this, map that. I didn't do it. So this doesn't work. So again, I'm gonna upload. And you know, like I could go through and I could I could program all of this ahead of time and like have all of these mistakes figured out before like I start recording and showing you guys, but like I kind of like them here because I do like you to recognize that like we all make mistakes, we all gotta like learn from our mistakes, and we gotta like figure our own mistakes out. Nobody's over my shoulder right now being like, oh yeah, this is the problem that you have, I gotta like think about it. So now, when I move, and this is a good example of why things need to get flipped around sometimes. When I move my joystick down, my arm moves up. When I move my joystick up, my arm moves down. That's like counterintuitive to like what it ought to be. So again, I'm going to come back up here and flip my numbers around so that my low end is 10, 23, and my high end is 0. And basically what that has done is it just now maps things the opposite direction. So now when I push that same joystick up, my arm goes up. When I push that same joystick down, my arm goes down. And now I have control over the middle servo, the right servo, whoa, 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 chill, 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 and the left servo. Now the only thing we need to do is add the claw. So for our claw, we need to know what values are equal to open and what values are equal to close. I need to look back at my values, so let me go check that out. Okay, so according to my cheat sheet from earlier, like my notes, my claw's closed at 105 and my claw's open at 45. Your values are probably different than that, but those are my values. So those are what I'm going to use within here. So again, we already have our button outputting, and our button is underneath of button value. So for our claw, we are going to create an if-else statement. So we are going to type if, and then in parentheses, we're going to say if button is equal to. Now you might have noticed that a lot of times I've been using one equal sign, and I refer to it as a set to, which is a definition. It means that this is set to that. It's going to be equal, like it's a command. Here, we're asking a question. It's basically like we can replace the word if with is. It's like, is button equal to? Remember, button is equal to 1 normally, and that's when our claw is going to be closed. So we're going to say, if button is equal to is going to be 2 equal signs, okay? 2 equal signs is read as equal to, 1 equal sign is read as set to. This is a definition once again. This is a question. If button is equal to 1, that's saying like if the button is not being pressed, because when it's not pressed it's 1, when it is pressed it is 0. We are then going to put this in a curly Q bracket, and if that's the case, we are going to claw dot right, and we want it to be closed when we're not touching anything, and close in my case is 105. So this is going to close the claw when the button is not pressed. Okay. Then we're going to create another if statement. All right, and in this case, we're going to say if button is equal to 0, which is when I have pressed the button. You can see that in like the down here when I'm pressing the button, it's 0. So if it is equal to 0 in this case, again, curly Q brackets, and inside claw dot right 45. That's going to open my claw. Open claw when the button is pressed. All right. Now at the end of this whole loop, Now at the end of this whole loop, we are going to add like a quick delay of 50 milliseconds. This just like slows some things down and helps our servos not like burn themselves up. Okay, so this is a delay to slow the loop time. Alright, so let's upload that. And let's see how this works here. So now when I push my button down, alright, so I just went to go test my code and realized that my button still isn't working, and it's because I forgot the value part. It's supposed to be if button value is equal to 1 and if button value is equal to 0. So again, we'll upload misspelled value somewhere. Alright, here we go. Third time's a charm. When I push on my... There we go. Okay, so when I push my button down, my claw opens. When I close my claw, or let my button go, my claw closes. Again, now we can like move it back, move it forward. We can pick it up and move it even further forward. We can turn it. We can open our claw and we can close our claw. Alright. And that, in a long-winded nutshell, is how we can control our system with a controller. So, again, if you're having issues, you got to go back through, check your code. I will include a copy of this code once I've added all of my comments, but check your code, make sure things look right, and see how things work out for you. Alright? If you need help, and you are in Mr. Van Vliet's class and I'm not with you, I am still available for extra help after school Tuesdays and Thursdays until 3:30. And you can also check the Open Lab schedule and come in and see me during Open Lab as well. Alright, I'm going to let you guys go now. This was a really long video. Thanks for sticking through it. We'll talk to you soon. Make sure, please, to like and subscribe. Peace.